presentation. Of course, if you have any kind of details that you might want to address regarding the charity project that we are supporting here, you can always ask questions within the chat. And at the end, we have a special question and answers section when we can discuss freely and have an interactive session all together about what we will tackle today. So as again, thank you very much all of you for joining our webinar today. As you might know, the most important topics that we will discuss today are the following. The holographic situation in Europe and holographic applications. We all know that for many years, holography has been seen as a technology that was very important for and is very important to set change and decide, let's say, the steps of interaction and also the reality that we want to put over and put on top of what we have already. Many of us chose and are choosing to offer, let's say, another type of reality, and this is the holographic reality, yeah, mixed reality, as we might call it, to express their, let's say, um, businesses, to promote their businesses, to find another way of interacting with the audience, to make the audience uh, enjoy their view, and of course make other things possible, such as, for example, holographic concerts that we will also discuss about today. Other types of holographic meetings, in case people cannot join on site and they want to be present virtually. And in the same time, we can also uh, have the case of a holographic assistance. Yeah. So all these three use cases will be tackled today, and of course, I will just start with mentioning our special guest here again, Real Fiction. As I mentioned before, is the leading global manufacturer of mixed reality solutions. They go from retail events up to brand activations. So they're very, very, very specific professionals into this mixed reality industry. The first part of the agenda is to settle you upon the main points of the charity project and its use cases. I will just go to the second part shortly to present the second topic of the agenda, which is to deep dive into the holograms world. Here, Raquel will make a video presentation, and in the same time, we'll have Enrico explaining the technology behind and the holographic assistant use case and the applications as well that are requested within this use case. As I already said, we will have the third part of the webinar today that will include the Q&A session. Here you are free to ask questions to our speakers, and of course we can address to you um, as as much as we can all the information that you might need. Okay, going forward, I will just go through the first part quickly together with you. So first of all, when we all hear about holograms, we do know that it sounds really interesting. I was amazed as well when hearing about the possibility of making a reality, a different reality, yeah? So bringing a sort of an object or something from the reality into a different perspective. And this is a very interesting thing that all of us are really aware of today, that this is possible. So we can make things work in the virtual reality as well, through holograms. And the word originated from a combination of two Greek words. One is holos, which means whole, and the other is gramma, which means message. So it's a whole message of reality, so that I can translate it, which come together to produce a complete message of the reality that we want to express. And this is a hologram. It's a three-dimensional image. Yeah. We do know that charity project aspires to leverage the benefits of intelligent, autonomous orchestration of cloud, edge, and network resources. Um, the charity project wants to create a symbiotic relationship, of course, between low and high latency infrastructures that will facilitate in the future the needs of emerging technologies. First of all, I wanted to mention here the fact that this intelligence tool that potentially tackle any kind of highly interactive class of services and applications will be validated within a wide class of highly anticipated applications characterized by extreme levels of interaction and data exchange between the end users and the application components. And we have to make a difference between the augmented reality, virtual reality, and holographic applications. Many people make a confusion between these three, let's say, um, these three meanings, yeah. But in the end, we do know that holographic applications represent a three-dimensional image that consists in mixed reality, so not augmented reality and not specifically virtual reality. Of course, it is a virtual reality because you just transform it into an online, into a virtual instance, but in the end it's not the same. So we just have to make a clear split between the meaning of these three items. What I wanted to mention within this charity project is that we have many outcomes that we want to achieve. First of all, we want to have a community-driven open source framework of this project. And this is to consist of a system that has a collection of tools, mechanism, and algorithm enabling the efficient and network-aware exploitation of edge resources and applications of holograms. In the same time, we do know that tools for the application providers um, have to be simplified and in the same time simplify the deployment and management of application components. Uh, and mostly we have to set this highly interactive applications mainly to adjust, let's say, towards the necessity on the market. So, of course, in the same time, as I mentioned here, Charity wants to provide holistic support for the orchestration of advanced media solutions, wants to develop highly interactive and collaborative services and applications, and intends to augment project visibility, outreach, and business sustainability. Yeah. Um, a few words about our holographic application use cases. First of all, I can say that Charity de develops and developed and still works within these use cases, applications, and as you can see in this image, we have many many connections here, many devices that are used. Of course, as you might see in the down part of the image, there is this mentioning of the end devices, which is augmented reality, holoprojector, and virtual reality. Of course, this is the access network as well, but in the end, all the applications that are developed within the charity project will be used for the purpose of holographic industry, and of course, any let's say extra development ideas will be discussed within the project, and of course um, will be settled according to the market development. I will just start by saying a few words about Hologramma 3D and its role within the charity project. We are just tackling two use cases. One of them is the holographic concert, and I will be very happy to share with you a short demo of how the holographic concert can go with a very interesting device, holographic device, who is named DreamOak Diamond. It's a very, very good one, a popular one. Many people use it during major events and not only. So we used the DreamOak Diamond to have a holographic concert possible. So I will share with you this first use case, example of our use case. And the first video is showing, of course, a holographic concert with the help of DreamOak Diamond. And the second video is actually the person who sings live from the other side, and it's registered, let's say, live, so that the image can be transferred on the holographic device, which is DreamOak Diamond. I will just give it a play, and shortly I will just play as well the second video after the first video ends. So you might see here how the person actually moves, like it's really real. It's all about the same moves, same voice. It's nothing different from, let's say, a real concert, live concert. Everybody has the opportunity to see this image that you are seeing from all corners, yeah, of the DreamOak Diamond, so they can see the whole image. It's accessible from all corners of, let's say, all sides of the audience. In the same time, as we can see, let me just give the sound a little bit lower. So she is singing here the same melody and just recording is going live. As you can see, here is the DreamOak Diamond, yeah, showing the holographic concert. Yeah. Okay. Going through a little bit through our use cases, I will just say that holograms, of course, we do know that are the emerging media of the future. Hologramma 3D, we have been in this market in Romania, for example, from 2007. And we are a provider of unique 3D holographic displays. We are the official distributor of Real Fiction for these display solutions. In the same time, as I said, our use cases contain 3D holographic displays that are inserted within the holographic concert and holographic meetings. The advantages, of course, are that the artist can perform in remote locations, and this is the most the biggest benefit that we can see, among of the fact that we can also share, let's say, bring other people on the stage, let's say, or on the in the meeting. So mainly this is the most important thing, that we can make people present from different locations in the world, no matter, let's say, the hour, no matter the perspective, the weather, whatever. What is most also important is that charity will support this use case by providing the cloud infrastructure and taking care of the service deployment and resource management. So this is the role that we will play, and of course, the charity will have as well, will offer their support for this use case to happen and to be possible. Uh, the next use case is the holographic assistant, as I mentioned, and this is a topic that will be handled by my colleague Enrico from Serial Technologies. Of course, he will discuss in detail all the user scenarios and also how the system recognizes and interprets the speech, and yeah, how the other details within the applications can be made very good, and of course in the same time um, manageable for the people that are using the solutions. Yeah, perfect. So what I will do here, I will just leave space for Raquel for the second part. She will start to talk a little bit about the role that real fiction has, the innovation, let's say, a role that real fiction has as well in Europe, and more details about how the business works in Europe, how the users um, are, let's say, expressing their will into deep diving into this holographic story. And so we will just invite here Raquel. And Raquel, you have the stage to further, yeah, tell us more about real fiction and how holographic world looks like from your perspective.
Perfect. Thank you very much. Thank you very much. First of all, I like to thank, of course, you for inviting me to take part of this webinar, to be part of this webinar, and also Charity Project for creating it. So it gives us the opportunity to talk a little bit more about this exciting and innovative technology. Yeah. So if you allow me, I'm just going to share my screen also. So I have some images to share with all of you and to show you. And I will, of course, talk a little bit about who we are. We are many companies worldwide at the moment that create and believe, of course, in the power and in the potential of this technology. Yeah? So Real Fiction is one of them. We are a Danish company located in Copenhagen, in Denmark. And if you allow me to present ourselves, of course, I will start by doing that. We have been established in 2008. It all started basically, I really like telling this story because that's actually the origins of who we are. And it all started in a fashion show in Italy. We were doing a show for Diesel, and we used at this time we used PG foils, which you know, I don't know if you are familiar with this, but before using the displays that we focus on at the moment, you know, there was this materials that we use in order to create holographic stages. Yeah. So we went to Italy to do this holographic show, and the customer Diesel, they love it so much that they asked us, of course, if we could do this something, you know, in a way that it was easier to transport and to bring around to other parts of the world. That's when the founders of real fiction sit down and they started to think of how they could do this in a much more efficient way. Yes, because they wanted to make it, they wanted to scale it down so we could share it more easily. Yeah, so that's how they came up with the idea of DreamWalk, which is our one of the products brands that we have, and I will show you a bit later. You know, all these products that we produce here, that we are the manufacturers of, and basically this is how the idea of DreamWalk came up, and we just wanted to bring the magic of holography to as many people as possible, in a way that it was very, very easy to install and integrate in various um, locations and in different places. That it didn't have to, that it didn't need, sorry, so much manpower to install. So anyone could do it. And actually, one of the main characteristics of our units is that they are plug and play. So you don't need technical skills to use them, and they are easily integrated anywhere. Yeah. So this is a little bit of our origins. On when we started in 2008, we were established as Real Fiction. We are today present in Nasdaq. We are listed, sorry, in Nasdaq in Sweden, and yeah, we call ourselves leaders in mixed reality, world leaders in mixed reality. And I will explain, of course, also what do we mean by mixed reality. And we are the manufacturers of different units. They are all called DreamWalk. And we are working worldwide with many, many, many different customers. We show here in in this slide, actually, we have been working with brands like Piaget, Gucci, Audi, Adidas, etc. And of course, we have received through the years, have been recognized with um, many, many different awards at CES in Las Vegas, Discovery Channel, etc. So I can, I was explaining you before how did we started in diesel, and actually the very first, this slide here. It shows the history, visual history of real fiction, a bit of our timeline and how did we started. We also created in Copenhagen back in 2002 the first hologram um, in a store here in Copenhagen. So basically, we recorded a girl changing clothes, and we just installed it. We installed it, sorry, in H&M. And the people who were passing by the window screen, they could see a girl changing clothes, and this, of course, you can imagine, generated a lot of attention. Not having a real person there, but just a hologram. So this was the very first installation that we did of a hologram here in Denmark. Yeah. And then, through the years, we started working, as I said, with the best brands in the world, brands who are looking, of course, for very innovative technology. They want to communicate the brand, they want to elevate it, and they want to present it to the world in a very different way. Yeah, this is holography is just the new thing basically out there. And as you very well explained before, Rosanna, there is not only holograms, or it's not the only we our format, sorry, our DreamWalk units, they are not the only way in which you can create holography. You also have augmented reality or virtual reality, but we want to focus, of course, in holography as a shared social experience. And when we say that we are world leaders of mixed reality, it means that our units, they allow you to have both elements. Yeah, they allow you to mix physical display, a physical object, sorry, with a 3D animation that can explain the story of the object that you are seeing. Yeah, and you don't need to have any headsets. You don't need to use any glasses. You can see this real time commented with the person that you are next to, and you can also easily share it in social media. Yeah. So we like saying that one of our strengths and what differentiates us from other companies is the possibility of enjoying holography without the use of headsets or glasses. Yeah. And yeah, in here, basically, we just tell how we started, from the very beginning until we produce in 2009. We were building momentum with the appearance in the market of the DreamWalk HD3. Of course, now we keep on upgrading our units just to make them better, to offer even better quality, better experiences. And in 2018, we launched the DreamWalk Diamond. And also, well, we just keep on developing and, as I said, upgrading all our units. In 2017, we also launched, I think it was the same year actually as DreamWalk Diamond, we launched a very new technology. It's called the D-Frame. And at the end of my presentation, I will show you all a video where you can see D-Frame in action. Is the best way of explaining this unique technology. We are the only ones in the world that can offer this kind of experience, of visual experience, and the frame is unique, and we are the only ones who have this technology in the world. And of course, holography keeps on developing. It has a huge momentum at the moment, recently, and we are also investing a lot of resources and time in bringing up the next technology, which is called Echo. And you can, of course, find also a lot of information about this new product in our website. But if we go back to the applications of our units, of our displays, in real picture, as I say, we work with very different customers. They all have a different profile. And if you ask us which are our main verticals, we focus mainly on retail, museums, events, and in-brand activations. Yeah. So we were present, or we are present, of course, in different retail spaces all over the world, where different companies and different brands, they purchase or they hire our units to basically showcase their brands for marketing campaign activations and marketing campaigns, etc. Yeah. Museums, for obvious reasons, our DreamWalk products, they offer a really innovative way of presenting all different kind of objects. So it's a really new way of bringing all objects or any kind of objects to life. It will create a lot of engagement, and we like also bringing the wow factor into the spaces where we place our units. Yeah, we want to surprise people and create some magic. Actually, this was one of our motto lines, magic matters, also very connected to the very, very beginning of holography with Pepper Ghosts, of course. And we are also leaders in events. When it comes, we provide our units also for different industries when they go to shows or fair trades all over the world, and they want to build a very innovative booth. They want to catch the viewers' attention, and they want to have, of course, more people visiting their booth. And the best way of doing it at the moment, of course, is by offering something totally different that people is not used to, and this is what we provide them with. Yeah, we provide them with these innovative communication platforms that they can actually use in order to explain the products. Some companies, for instance, they have very big units that they are not able to transport from fair to fair. So this is a unique way of doing it. They can hire one of our displays, and then they can, of course, represent the products they have using holography. Yeah. Of course, holography, the displays that we produce, they are interactive. So you can use them, and you can add to them any sort of interactivity. So people can engage with them, and they can find out all the features that the products have, in a very engaging and entertaining way, of course. And yeah, basically, the values of holography, of our mixed reality displays, which are our propositions. As I've been saying, of course, we want to create a wow factor. And this is very important for us, the visual quality of DreamHawk, we are very proud. We are very proud of saying that we offer displays that create magic moments. And this is possible because the technology that we create, it enables the reproduction of images of 3D content that it has a really high quality um, images. Yeah, so for us this is very important. When you want to communicate something, when you have a brand, if you are Adidas, for example, you want to present a new shoe that you are doing, and you want to explain the different features of the shoes. You want to do it in a way that doesn't, that the quality of the images that you are showing is really high, and you also want to create magic with that. You can, holography allows you to mix real images, real pictures, but it also allows you to be very imaginative. When you want to create something in 3D, the sky is the limit, basically, because you can be as creative as you want using holography. Yeah? And our units, therefore, they help you build this wow factor. They also generate a lot of attention because wherever you place them, people will look into it. They will wonder what is the images, where are they coming from? How do they do them? So of course, people will go into the unit. They will look at it. Not only the animation. That is going to be like incredible, and amazing. Of course, is 3D, is new, it's very different from the familiar and the typical flat screen that we all have. So they will just approach the units and they will engage immediately with the content that they are seeing. And this, of course, will allow brands that people look into their content, they remember them, sorry, and they interact and they engage with the brand more easily. Yeah. And yes, so engagement, wow factor, uh, allowing people, of course, to share what they see. Nowadays, we all have a mobile phone in our pockets, and the moment we see something that we love, we want to record it and we want to upload it to our social media, we want to share it. So, of course, this will help brands to become more visible in all different platforms, when people go and they see something that is very new and very innovative, very special, they will record it and they will share with friends. So this, of course, will help brands to become more visible all over. Yeah, and we generate traffic. Of course, the people will go and then. Yeah, basically, this is something that holography will allow you to do when you use it for the promotion of your brand. You will create a lot of awareness and attention. And then definitely this is something that will help you to increase your sales. Yeah. So this is something that our customers, they are very interested in, using holography as a way of increasing sales. And then, if this is a very common question that people ask, which kind of units do you have? Do you have them in different sizes, different models? Not all customers are the same. Some of them, they have small products and they want to, they don't need a very big unit in order to show, I don't know, a watch. But of course, we provide different, our portfolio has different models of DreamHawk units. The smallest products that we have at the moment, they are called the DreamHawk AC3.2 and the DreamHawk Pop 3. The quality of all the units that we have is the same. It's a high quality displays, and we recommend to use one or the other depending, of course, of the space that you have, and also well, of course, definitely budget. The bigger the unit, it doesn't really matter. But in this case, yes, the bigger our units, they are more pricey. But the wow effect is the same in all of them. Yeah. As you see, the smallest units that we have, the DreamHawk EC3 and the Pop 3, the DreamHawk EC3 actually is three-sided view. That means that you can see the animation from three different sides. The POP3 is single or front-sided view, sorry. The XL5 is the big brother of the HD3.2. So they are the same, but the XL5, it comes with 4K resolution, which means that the image of the units is is more crisp in a way. The black is blacker, yeah. So well, 4K definitely, and is also bigger in size, which allows you to have bigger object inside the display, and for sure the bigger animation, yeah. So the DreamWalk XL5 is really good for rentals. To bring into thirds, you know, is yeah, is one of our star units for sure. And then we have the DreamWalk Diamond. You show us a video clip with the Diamond, Rosanna. And we love this unit, of course, you know, is the king of fairs and events, special integration and brand activations. Definitely the DreamWalk Diamond is a winner. It's 4K resolution and it's 360 view, which means that people can see the animation inside the diamond from all angles in the unit. Yeah? So they can walk around it and the animation will be seen from all different angles all over the unit, yeah? All around the unit, sorry. Of course, the diamond is bigger in size, so it will allow you also to have a bigger object. The XXL3 also available in 4K, you know, this is also perfect if you want to show or if you want to use, you want to promote a bigger object and you don't have space enough in the XL5, then we would of course recommend either the Diamond or the XXL3. And in here, it very much depends which kind of design you like the most. And then the last, but not least, is the D-frame. This is like, as I said before, is a unique technology. We are the only ones in the world who have this kind of optic. I always like saying that D-frame optic is the same kind of technology that NASA uses to see the universe. So what we do with DreamWalk, you know, is playing the magic inside the box. You have a display, and then I will come now with the videos so you can see them in action, of course. So all DreamWorks units, what they do is playing the magic inside the display. You can place also an object, so you will have mixed reality, or you can do it just plain animation, no object, yeah? But the frame, it will bring the magic outside the box. So when you look through the lens of the frame, you will see an animation blending into the real world. And this is truly magical. It's really yeah, you can have also the animation in real size. So the frame allows you to have like a real size person hologram, but it will also allow you to, for instance, I don't know, represent a dinosaur. If you have a deep frame in a museum, then you can allow people to see dinosaurs in real size, how they used to be in real size. So you can have also like a car. So let's say that you are Mercedes or Audi, you will have that possibility of showing your product in real size, yeah, 4K. So the quality of the animation will be really good, but you will see how it works now, because I think that I am running out of time, so I want to show you the videos. And then, you know, I really like this part now because it's just more like for, yeah, just seeing is believing, of course, and we truly believe that. And so I want to leave you now with, I'm not gonna talk while you see the video. So in here you will see a presentation of real fiction. This is our show reel. And yeah, then let's go. Let's show you what real fiction is about.
Beautiful mind.
Okay, so this is basically real fiction in a nutshell, and you have been able to see in this video, you know, that how our units perform in real life, in real situations, in different contexts, fairs, retail, etc. So in the next video, you know, this is a specific case study. You know, we have plenty of case studies. You can see them all in our website. But we chose this one because we really like the animation they created. For this, they wanted to explain people how important it is to take care of your bike, especially if you come from Holland or from Denmark, where we use the bike very often for daily transportation. So this is a good example of how Shimano did it. You will see the animation now. And yeah, I hope you like it. Yeah, we really like this one because they also show that our units, they can be interactive. And basically, you know, you can display with remote any kind of product that you want. You can display, you know, like from very luxurious products to something like shampoo, for example. So basically, you can communicate wherever in remote in a very innovative, as you see, in a very original and interactive way also. So the last slide here is going to be the frame, and this case study we did last year in New York. We took 2 units to New York Stock Exchange, and this was a real it was a milestone for us because it's the first time that we use the frame outdoors in daylight, and it was a really good match for the technology because the customer, it was if they create this huge, it's like a drone, huge drone to transport people, and they wanted to have a way of presenting it to people without having the physical object there. So, and that's why they call us, and this is what we did for IF in New York last year. It was last May. Okay, so that's going to be that's it from me, and thank you very much again for allowing me to present real fiction. And of course, I will be available at the end of the webinar. If you have any questions, I'll be happy to answer them. Thank you very much.
Thank you very much, Raquel. It was a very interesting presentation, and as you mentioned, this social interaction, it's very important, and how people actually reach out to holography to, yeah, mirror the reality that surrounds us. So, as the next step, I will invite Enrico, our colleague from the charity project, who will further present to us, yeah, the holographic applications and the holographic assistant use case. So thank you very much, Enrico. So you have the floor now.
Thank you, Roxana. Thank you all for joining this webinar. In my track, I will demonstrate. I will explain a bit more about cherry-related things like our use case, um, the holographic assistant, and I want to go a little bit deep into real-time 3D holography, the next generation of holographic display technology. About our use case, what we want to do with this use case in charity is to show basically that we can do holography and cloud-based processing the same time. We want to show a use case where we have an holographic assistant. It's something like an avatar on a holographic display in 3D space. We have a holographic display with eye tracking. The observer is in front of this display, is tracked by the eye tracking, and the observer or the person in front can speak with this assistant to ask for certain things, to get information about different things. And the specialty, what we want to achieve is cloud-based content generation in combination with hologram computation, which is then done locally. So the key features, what we want to do is we want to have a Unity 3D based edge processing where the content is generated in the cloud, and then this content is streamed frame by frame using a specific 3D point cloud method, which is quite novel in this version. And additional services in the cloud by using the charity framework with support of that is to realize all this special assistant functionality like gathering information, voice processing, and things like that. That means the user can talk with this assistant with natural voice, and he will get an answer for it. But basically, these voice topics are not the main focus of this use case. It's more that we have an overall package of a nice application based on cloud based processing. Um, in the next, I would just like to give a more overview about holography in general. There are several technologies to display information in space or in air available today, and they are often called holograms or used with the term hologram. But in principle, they are not really holograms. It's just often used this term. Holography, the principles of it were invented by Dennis Gabor. And in 1971, he received the Physics Nobel Prize for his work. But even other researchers did a lot of things, a lot of contributions to holography. And I want to explain what is the difference between holograms and not holograms. So one key feature of holograms or holography is that the eye can focus naturally between different depths in space, like is with natural viewing. When you look at your cup on your desk or on your monitor or to the outside, your eye has a little lens, and it focuses between different depths. And this is also possible with a hologram. And you can also use a camera for it to prove it when you change the focus of the camera with a At DSLR, for instance, you can manually change the focus. You can see the different depths in the hologram. Another feature of holography is that you can look from different directions onto the hologram and you see different perspectives of the objects. It means the objects can be seen from different angles and they look exactly like they would be really there, like real objects. It means with a hologram you can see 3D like you are used to with normal seeing. And objects itself have an intrinsic depth. That means they are not flat objects somewhere in space. They are really deep and have own properties, own features, own looking. So basically, there are holograms, they are magic-like effects, but even 3D is unfortunately not holography. For instance, things like when you project information on foils or using some glass, special glasses. When you use 3D stereo, like in the cinema or on 3D TVs, even light field displays and multi-view displays. Also VR headsets, for instance, this is not holography, it's 3D, stereo 3D. And even there are some effects using LEDs and possibly fans that you can create some magic-like things. It's also not a hologram. I want to explain what a hologram is. Per definition, you can even look on Wikipedia to read about it. A hologram is simply spoken a wave field which modulates light. That means, in principle, when you look at this picture here, you have a coherent light which illuminates the hologram, and based on this, by diffraction and by overlaying of different light waves, the hologram is reconstructed in space and you see this virtual image. This, for example, is an pattern how a hologram looks like. In this case, a holographic film. When you look under a microscope, there are millions of dots within this small area. It has a really big resolution and there's a lot of information inside. And this is an example with this little mouse here, an example of a reconstruction using this coherent laser illumination. You can see this mouse from different perspectives when you look from different sides, from different angles, and reconstructs in 3D. That means with both eyes you can see even those 3D with the same image, with the same hologram pattern. But now this is the approach to classic holography. Now we also want to do it in real time. But why want we do it in real time? As I said, the difference or the speciality of holograms, of holography, is that you can have a natural viewing like you do all the day with your eyes. You're looking on objects. You have always the right focus and the right convergence of object to see. Focus is with your small lens in your eye, and the convergence is how your eyes rotate on a certain object to see it somewhere in space. With a 3D stereo display, for instance, where you have two pictures, basically spoken, which come from a stereo display, there is a mismatch in this system. The focus of your eyes needs to be on this holographic on this stereo display plane, but the convergence of your eye is different. That means if you have especially large depths in your 3D scene, there is a mismatch in your brain, and you get tired or you get a headache or have some discomfort when looking at stereo displays. That's the reason why depth in 3D stereo is often quite shallow. For instance, in the cinema, if you have a movie with mountains in the backside, in the background, they are about 1 meter behind the screen. That's not real. So you need to limit depth with stereo-based approaches. But with holography, you have the full freedom of full depth. You can show any depth how you want. That's the advantage of holography, but what is the challenge? Because then everybody would make holograms or real holograms. It is really compute intensive. As a holography, especially the classic holography, needs a lot of computation, and it needs to be in real time very special light modulators so that you can show or can do this reconstruction of these special hologram patterns. And this is basically not possible today and will also not be possible in the near future. But we invented some new approach where we limited the computation power and we simplified the requirements to these modulators. And I explain it like here. Here is an image of, or an example of classic holography. You have a modulator with an enormous resolution. For example, here 250,000 by HDTV resolution, which is simply not possible. You cannot drive this displays and you can even not compute such information in real time. So we thought about why do we need to compute all this large angular space? We just need the information which is seen by the eyes, by the both eyes, and that's the approach for this. That we just compute these small areas, and this has the advantage that we also need not this large resolution in the modulator. That means we can use today's display technology available with standard display pixel sizes in the range of 20 to 70 micrometers. This is quite typical in current display fabs. There needs to be some more things added. We need to modulate phase and amplitude with these displays. Typical displays you have on your desk are normally only amplitude modulators. So there needs to be some changes in the technology, but it's not that much that you need 1 micrometer small pixels or like that. So that's not needed. So, but at the end, holography is still based on physics, on real physics. That means on diffraction of light, and diffraction of light you made from the physics school lessons. That light which passes some grid creates some diffractions, and this is the basic principle of holography. We have a diffraction angle here where you see the hologram in space, and the information here is then encoded in the hologram and to be seen by the eye. And how does it basically work? First, what we need to create a hologram is that we need at least for each eye, because we have two eyes and two viewing windows from where we see the hologram, we need two views, a left view and a right view, and we need depth information. That means the depth information is needed so that we can encode this focus information for your eye so that you can look naturally, like with natural viewing on this hologram. And what we then do, we take each of these scene points in these two views and compute a separate hologram for each eye. And there we add for each scene point in the scene, we create a small lens, a holographic lens, and those lenses are then added together, or also called superpositioning. And finally, we get a sum of all these billion lenses here in one hologram. And this is the pattern which is then written to the modulator to reconstruct the information in space. This is just a simple example. What we do, we have a laser, we have a coherent laser. Coherent means that the laser, that the light information across the display has always the same phase. You can read it on Wikipedia. It's not the time to explain this in more depth. So, but basically, just imagine you have a coherent laser light which passes this holographic lens, which is consisting of many holographic pixels, and then somewhere in space, which is defined by the focus, this light point is created, and this we do a million times so that we have a scene with many millions of scene points. So, and finally, you see a scene, a 3D scene with high resolution, and you can move in front of this holographic display and see the scene like it is stationary at the same point in space. It means you can look around this object like you're doing when you're looking at a natural or a real object. And to show this a little bit more, to give a more simpler explanation, we have a video prepared. There you see how this eye tracking system works. The eye is both eyes are tracked by this camera system and the processing. And we create these scene points in space by creating the appropriate lenses on the holographic display. And this then done for millions of scene points creates finally the hologram. And this is reconstructed then in space by using the laser, which illuminates the hologram. And then you can see an interactive scene. You can do any application. There are a lot of use cases like gaming, medical, professional work like CAD or whatever. Is a lot of possibilities. And with this video, I want to show just how it looks with a real hologram. This was captured with a very old system. That's the reason why it's a little bit blurry. But it just wants to show how it basically works with eye tracking. I repeat it again. So here you see the observer moves in front of the display and the hologram is shown from different perspectives, and you can look around these virtual objects. So and here you see some fine lines. This shows the fine resolution the hologram can achieve, and this is complete in 3D in space. And here we have a more modern generation of holographic displays. We want to demonstrate how this focus feature works. I mentioned in the beginning, we have some plastic figures here in front of this display. This is the holographic display, and I can show you different focus settings with our camera. So here we focus on the first object in front. This is some little R2D2. In fact, it's Star Wars. Why not? So here you see this little Luke Skywalker, and what you also see is this holographic object is also in focus. That means you can place objects really somewhere in space, in any depth, and with the camera we can prove that these objects are really there. So the light which is used to reconstruct this object is not on the display plane, it's really in space. So that's the proof that this information is really there. Here you see how we focus on the backside of the holographic displays. There is this space station, and you see how the focus gets more and more blurry in front of these objects. Now I zoom to the sun, and it's more and more blurry here. So it's like with real objects, and that's the proof that this is a real hologram. So now's the point. You know now a bit more about holography and 3D holography, and now we think of edge and cloud computing, and the question is, does this work together? What we want to do, or what we need to do, is to generate this 3D content in the cloud or in the edge system. But we also need to achieve these requirements to delay and frame rate. That means when we move in front of the holographic display, we want to have an immediate feedback from the display to see the new perspective of the scene. And when we think of cloud-based scenarios where the information from the eye tracker is sent to the cloud, there the new frame is generated, the new content is rendered, and then it's sent back to the client local domain. Then the hologram is computed, and then it's displayed on the holographic display. And this is a lot of time, and you get some real delay in it, and it's quite not usable in this scenario. So, and this would totally destroy this like real experience you are expecting from such a holographic display. So we need some way to update our views, but still create the content in the cloud. So yeah. And that's the main challenge of this use case. So, but there's a solution which we sort of the promise or the most promising solution for this is that we create the content still in the cloud, but do not create a single image, a single view for each eye. We create instead a 3D point cloud, but with a very limited viewing angle. That means typically when you hear the word point cloud, or you maybe know it already, this is something that you can represent some 3D object, and you see the 3D object from any angle. You can rotate it. You can even zoom in and see more details or lesser details if you zoom out. So you have a full 360-degree viewability of these point cloud objects. But for this use case, it's not needed to encode all the the views around this object. We just need a view onto a on a rendered scene. As that means we do not encode a certain object which we want to show. We encode a complete scene, and this can be any scene. It can be a game scene. It can be like this in the use case an assistant scene where you see different objects. So this is not comparable to classic 3D point cloud models. It's more a certain approach to some view generation. Yeah. So this means we have only a limited viewing angle on our 3D scene, but we have more data than just a single view. So, and then when we transform this, when you transfer this this data to the local domain, we have the option to create any view on our local site which we need. So this is just some example for this. We have a Unity system running on the edge domain. That means there we create the content and we create this 3D point cloud there. And then in the next step, we transfer this 3D point cloud stream to our local domain. And there we are then able to create those views which we actually need dependent on the current position of your eye. And this is a different position than it was when we created this scene in the edge. So with this approach, it could be possible or would be possible to achieve both requirements, that we have a quick delay, a short delay, and we can compute content in the edge. And this then now applied to our holographic assistant use case. I will just give you some more details about it. So this is an overview of the software modules in the use case. We have a user which is in front of the holographic display. It's tracked by the eye tracking. So now we can send this eye position data to our edge-based processing. There we render the content in Unity. We create this point cloud and we compress the point cloud. And this can even use things like differentiation methods so that we increase data transfer rates or reduce the amount of data to be transferred if we only transfer what has changed from frame to frame, for instance. So, and then we have this streaming to the local system, to the local domain, and there we decode this point cloud, and then based on eye tracking, we can pick the current eye location, which is quite different from that which we sent first to here, because in the meantime, there are, let's say, 200 milliseconds passed already. So we have a newer eye position, which is more accurate. And from this, we can then generate the actual views which we really need for our current position regarding the current location of the observer. And this then fed into the hologram computation brings us very quickly this hologram which we need according to the user position. And in addition to that, we have our other computation modules for these services for, let's say, text to speech, speech to text, some use case data, and so on. So, and we will guarantee all these holographic requirements, these parameters to holography by, in addition, having some monitoring functions so that the charity cloud detects if there are some inconsistencies or some parameters running out of range. So the charity framework can then react to that to do some orchestration tasks like moving some virtual network functions to a different location or things like that, so that just the function of the overall application is still guaranteed. This is just a quick overview about the charity architecture. Just a quick overview. We have our XR applications here with different network functions. That could be VMs or microservices. This is just the software which is feeding the use case with information and with data. We have these monitoring agents which are connected to the device or to the functions itself to gather or to collect all this information and then to check if everything is right or not. And a decision engine then decides what should be done to guarantee the proper functionality of this use case or of this application. And all this is then managed by the by the orchestration. There we define blueprints to define how these use cases are built up with which network functions, also which microservice, which VMs are needed, which network resources are needed, and so on. And this is all then managed by the charity network, so that at the end, the overall network or cloud-based application is working as expected. And this then just shown within the context of the use case. We have several modules here. This is the same structure as I showed some slides before. We have the software modules here, and we have different parameters. We can see which bandwidths are required between each component. Yeah, and finally the orchestration is managing everything. So. And what the specialty of this use case also is that we use some heavy amount of GPU computing, because all the content rendering and also point cloud generation, compression, decompression, and even though then also the hologram computation is also based on GPU computing, that means to achieve this high performance, this is needed for it. So I want just to mention that the charity partner CNR is supporting the work on the streaming point cloud approach together with us, so that we finally get a solution for charity. And at the end of my presentation, I would just give you some first impression of our implementation of this assistant. This is just some preliminary scenario, and these are just some single test views so that you can see how it basically could look like. As this is not a hologram, because we cannot show a hologram here on a normal screen, so just that you see how it could look like. So we have maybe some first scenario is just some kind of welcome scenario. We can trigger the assistant that it's properly prepared for answering our questions. We could, for instance, ask for the weather. He would give an answer and show contextualized information on the screen, on the hologram, so that we have different objects in depth. And we could ask for some different use cases like getting entertained. And other use cases are also prepared, something like that you request for different stock information, or possibly we could connect to a chatbot where we can talk just with the assistant, and using a chatbot in the cloud, it gives us then answers which are then pinged back to the user, and so on. So this is just some overview. As I said, the use cases of this assistant itself is not our main focus. It's just that we show an overall package of a working system using this point cloud approach. So basically that was all I wanted to explain. If you have any more questions or any questions, do not hesitate to ask. Thank you very much for joining. And that's all.
Thank you very much, Enrico. It was really interesting. Also, your topic. Actually, there are some questions. There is one from Jessica Rood, who asked for Enrico's email address, and other two technical direct questions were from Fatman. The first one is addressed to Enrico. Have you seen Real Fiction's idea of the project Echo? And what do you think is the biggest difference between your holography and the Real Fiction ones?
Okay. Yeah, basically there is not so much information about this project Echo, but as what I read is that it's based on light field, right? Oracle, is this right?
Yeah, basically,
Yeah.
yeah.
So the difference between light field and holography is that that light field is basically also based on stereo. That means with light field you can at least create a very high number of certain views of the scene, of the 3D scene, but the information is still on the screen. As it means the light field is let's say a kind of multi-view stereo display. It's just another option that you have more finer ways to control this generation of views. Also, this is from my side. I don't know if this is correct from your side, Rachel.
Yeah, well, I am basically in Real Fiction. I am not a technical person.
Yeah.
I'm not involved in the development of Echo, but
Yeah.
Well,
but
of
yeah,
course, sorry,
okay.
what we can say about this technology, this new technology is as you explained, it will be just a screen um, projecting a 3D image that multiple viewers will be able to see at the same time without the need of using glasses or headsets. So this is as much as I can tell about Echo. We are very excited, of course, and this year we hope and we actually plan to be able to show the product, within 2023. So it's coming.
Cool.
Yeah, and the
Looking
difference then
forward
I
to
think
it.
is that the light field display does not generate the focus information. So that's the difference to holography. With holography, you create these objects really in space, as I shown with these images with the camera, and there you can really focus on different depths. And this is basically not possible with light field, and also not with stereo. And yeah, that's I think the main difference.
Okay. Thank you. One question, Raquel. Did you attend the internal Real Fiction Echo Pro demonstration? And if yes, what are your thoughts about it? How do you feel it?
Good question. And no, I mean, it's of course a lot of interest around eco. And no, I didn't attend it, but as I said, I have seen few of the developments of the technology, but it's nothing that we can share right now. I mean, we have a lot of information in the website, and I'm pretty sure it's going to be very excited. And we, as I said, we hope to bring something to the general public, within 2023. So for now, this is all I can share related to Echo, but I'm pretty sure it's going to be a really exciting technology. Yeah.
Great, perfect. We are looking forward to it. Okay, good. Other questions, everybody? Anybody else? Or I will just ask some of my questions to the speakers. Okay, so I will just continue. From your perspective, which would be the most convenient improvements that the holographic devices will need to have in the next period? Let's say from both a commercial perspective and technical perspective, like an advantage. I will start with Raquel, like your vision. Let's say taking into consideration the need for from the market and as well how you felt at this moment. Yeah.
Yeah, thank you, Rosanna. I mean, from my perspective, what I've seen every day here in Real Fiction, in the sales department is, of course, that brands, they are in need of new ways of communicating their products. We are always looking for something new, something impactful, something that help us to generate people's attention because this actually sells more. So in that respect, holography or 3D animations, of course, they have a huge potential and an incredible future ahead of us, everyone working in this field. So from that perspective, I think that brands or industries, they don't have to, when we think of brands, we are thinking always on retail, but, holography, 3D animation, it can be used in any single field that you can think of, It will be, of course, very, very important for medical purposes, not only just commercial, but also for research. As I said before, museums, is something important, how can you bring the past into the future, into the present, into the future, how we can explain for educational purposes, holography is going to be really, really important. Because of course of the engagement, and the different ways in which it allows you to see something, as my colleague says here, we see the world in 3D every day, so why not trying to develop a technology that can allow us to show the world the way we see it. And yeah, it's been considered that the holy grail, of holography, bringing something to the world that can actually develop, that can actually give to people, this kind of experience. But of course it will come, it's just a matter of time, and actually you also asked me which are the most important technical aspects of holography, how can it be improved, as I think, I mean, if I'm not wrong, this is what you ask.
Mhm.
For me, from the commercial need, from the commercial perspective, purely from the commercial perspective, I think what people want is engagement and sharing,
Mhm.
because this is part of our human nature, we want to be entertained, we want to be wowed, and we also want to share this with others. So just keep on developing technologies, that they allow people to engage with what they see, to be creative, not only to passively consume, but also to be part of what they see, So interactivity is super important. Is highly demanded by our customers. How can we play with the holographic displays that you sell? And it's possible. All our displays are interactive, so there are many different ways in which you can interact with them. So for me, from the commercial perspective, interactivity, more tools that allow people to play with the displays, not to be so scared of holography, or 3D, just to make it more approachable, to make it more yeah, to bring it to people, basically, to allow them to not be so scared, not thinking of it as a very futuristic thing, but something that is already here and is going nowhere, basically.
Perfect. Thank you. From your perspective, Enrico, what would be, let's say, the improvements that you will see beneficial for the future of holography?
Yeah, basically, to be honest, also we are not currently selling any products, and it's also not our plan to sell products. We are developing the basic technology behind it, behind through 3D holography, and um, currently we are yeah developing together with partners, with different partners from different areas in the world. For instance, in Asia, in also in Europe, with, let's say, display makers, laser makers, component makers, Zeiss, for instance, and many partners we have. We developed the basic technology to make this principle of 3D holography possible for future products. So that means that's the next step or in our roadmap, that we want to make this technology available to be integrated into products, and this could be products from any display maker in the world. So we want to license this to display makers. So, and there are still a lot of things to solve. It's quite on a good way, but there are still some issues which we have. Um, but it's all solvable at the end. And the target for this is that we get a new era of display technology in the market, which
Mm-hmm.
creates objects and creates content in this way as you expect it. Let's say you have a video conference. It is not anymore that you have a flat image on the screen. You have your grandma, for instance, on the other side of the world. You see her really in 3D, like she would be really there, for instance. And that's our goal, that we bring this technology to market, because this will be a really a big step forward. Yeah, to have a new area of content. Also things like gaming, or and also in the professional market, like CAD designers, they can see their models and their 3D data as it would be a real object in space. So you do not need to prototype anymore any things to see it real. You can directly see it on your display, and that's our goal. Yeah. There are a lot of other applications which could benefit from that.
Interesting. Thank you. I have another question that would be maybe more, or let's say in terms of addressing the users. What kind of request did I don't know, challenge you in your activity? For example, here I would address especially Raquel. From my experience as a sales director, I do know that when talking to clients, many come to us and say, "Hey, I was thinking of making this scenario in outdoor with a nice holography and with this dimension. Let's say we have this script prepared." What was the most challenging request from a client in terms of mixed reality that you
Yeah,
encountered so far?
yeah, good question. I mean, the first thing that we say when we have customers who come to us and they want a stage solution, the first thing that we say is that our displays, unfortunately, they are not the stage solutions. So, it's like, of course, we have all seen, I hope, I don't know, Star Wars, and we think of holography, that's something that can be like that, that we can actually manipulate light in that way to make it, or we have seen how, for example, Madonna makes a concert, and she appears in a hologram and everybody can see at the same time, and it actually looks like you are seeing it on the television, but it's not possible at the moment to do something like that. Or if it is, it requires a lot of manpower. We used to do it with PG foil, as I said in my presentation at the beginning, but this is something that it's complicated to create solutions like this. It's possible, but real fiction, this is not our specialty. So we don't create solutions like this. And from that perspective, it's not a challenge for us because we are very determined, to bring experiences in 3D experiences, holographic experiences in a very different formats. So, but yes, it could be something that, I mean, it would be amazing to be able to give people this kind of holographic experience the way we have seen it in the cinema, the way we imagine it, but we don't do it in real fiction. We do something different.
Thank you very much. Enrico, from your perspective, technically speaking, which was the most challenging part of the holographic applications that you can say that was, I don't know, a really step forward into what you're doing as serial technologies?
Yeah, basically it was the availability of components. You know maybe the problem. You have a good idea. You want to show it to customers or to partners, but you cannot since you have not hardware for it. And that is the big issue. So what we made in the first step is that we looked on the market and we misused several components which are not made for holography. They are, for instance, we used some X-ray panels which are used for X-ray visualization, but they had some properties which could enable basically holography, and this was also a starting point for us that we had the option to create a hologram using some components, some special components on the market, and this was the basis for our first prototype, and we showed this to a big public audience in Asia, especially in Japan, in a big display fair, and there we had a lot of resonance for it, very positive resonance, and this was also the groundbreaking step to further proceed with this technology. And then we got more and more to find partners who even made us then very special LCD components in their big fabs. They made a special line only for us to create displays in this. You can imagine these large fabs, they have 100,000 displays, I don't know, per month or something, and they created for us a slot to make displays specially for holography. And this is something, where we said, wow, and that they also see this potential for this technology.
Rosanna, sorry, I would like to, because now that I was just thinking about these challenges, and considering the technology that we have, of course, we have been requested to do crazy things that we managed to do. For example, during the COVID, we were approached by a company in Norway, and they wanted to show a theater play but they couldn't do it in the traditional way, you know, just having the stage and the actors and having a lot of people gather at the same time because of obviously COVID, yeah. So what we did, it was using the deep frame, you know, and allowing people 2 by 2 being able to see the play in the scenario where they were doing it before, you know, but this time around, you know, the actors, they were recorded previously, you know, and they were presented it with a different, you know, and people, they loved the solution. And this was for us like something crazy to do back at then, you know, in the pandemic, you know, we had to go there and we had the installation. So yeah, I mean, we were presented with crazy ideas and we did them. But yeah, I think, you know, I'm not the technical person in real fiction. I'm not the research and development, you know, I'm just working in sales. But I have to say that every single request of people wanting us to do something crazy, you know, I think it's not a limitation, it's a push, yeah. And we like to be challenged, you know, and I think that part of this push for give us more, you know, is behind all the things that we have done since we started. So all the developments in our displays, you know, and bringing new units, you know, creating the frame, creating Dream of Diamond, working right now in Echo is just like this push for give us more, you know, what's next, you know. So challenges are always they're always great, you know, and this is actually what will drive this kind of technology forward, definitely.
Yeah, pretty interesting. The deep frame actually, it is quite entertaining for the audience. But as from our experience, it is used in particular situations, and it is pretty wonderful thing that the deep frame does. Cool. So, since no other questions are here, I guess that we can call off the meeting. Thank you very much, Raquel. Thank you very much, Enrico. Thank you very much, everyone that is here participating. If there is no other question in the chat or nobody wants to ask something, anybody wants to sell something in the to say something in the end? No.
For me, you. Thank you, everybody, for attending.
Thank you very much.
Thank you
So
very
I
much
guess
for
that this
joining.
type of webinars will be very successful as well for the future. So we won't stop here. We'll just find other topics next time. Thank you very much, everyone. Have a nice evening. Enjoy the day forward, and see you next time with new hot topics. Okay? Thank you.
Thank you. Thank you, Roxana,
Bye,
for hosting.
everyone. See
Thank you.
you. Thank you very much.
Bye.
Bye.
Bye.